So it's awesome to be here. It's great to be part of the ARM Dev Summit and to be participating in this. There's been a lot of interesting other workshops that I've seen and appreciate the kind of the building around this whole platform and everything that can run on ARM. Sensory's worked closely with ARM for a lot of years, and so it's fantastic to actually have so many different platforms that we can run on. And so I'm going to spend some time today talking a little bit about the technologies and different things that we can run on ARM platforms. And then really the bulk of this workshop really will be a workshop where we're going to get into our tool VoiceHub and build out some actual applications that can run and command sets, simple, starting with just a wake word. And then we're going to go into phrase spotted commands that can run on a variety of different ARM platforms, and then our truly natural that can run on the M7 today. And so let's just jump into this. So who is Sensory? I think that I would guess that most of you attending have heard of Sensory, know who we are. We've been at this for more than 25 years. We're not a startup. We're not a new player in this space. We've been doing voice for a long time. We actually started back in 1994, and I started with the company as it was just getting started as well. So I've been here a lot of years. And we started as a little chip company. We were doing a little 8-bit microcontroller that could do speech recognition. And we added hardware assist modules back then because we didn't have DSPs and other things that are so prevalent today. And we started with that, and our goal was come out with a single chip that could do speech recognition and speech output and provide this new experience to users about being able to talk to products. And back in '94, speech recognition was still really new, and I mean, it had been around for a lot of years before then, but as far as actually getting into consumer kinds of products, it wasn't trusted, it wasn't known. And so our first customers in the first couple of years were all toy companies because kids were like, yeah, I'll talk to things. And I clearly remember, even going back, 15, 17 years ago, talking with appliance companies about, hey, we should add voice control to appliances. And back then the comment was, well, I don't know. I think talking to things would be weird. Talking to a microwave or an oven, that people won't want to do that. And it's amazing to see over the number of years that I've been with Sensory and that Sensory's been around, the change in acceptance, the change in the performance, the change in the technologies and all that we can do. And I share that little brief history with you because we started at Sensory, we started with a focus on running on a little 8-bit microcontroller, as opposed to, well, we're running in the cloud, and now how do we fit it down to an M33 or an M0 or an M4? And that's a really hard path to go. But in our background and experience, we started very small. And so expanding and going into these other platforms, when we looked at these things coming from our own chips to now being a complete software company, we don't make our own chips anymore. There's a lot more horsepower and there's a lot more processing, and there's a lot more memory. We used to run everything in 2 KB of RAM way back in the day. And so, but our focus from the very beginning has been around improving user experience. The name Sensory actually came from the idea of working with the senses. And we started with speech, which was probably one of the hardest ones, but today we do both speech and computer vision as part of those sensory experiences. For sure, we've been pioneers in edge AI. Everything that I'm going to show you today all runs 100% on device. There's no cloud touch needed. We are introducing our new private cloud Sensory cloud solution at CES coming up here in a couple of months, with the idea of running biometrics and taking advantage of some cloud options that we have. And providing that private cloud experience means that the cloud, our container, our technology can run on the customer's cloud, as an example, as opposed to forcing everything to go through our cloud or Amazon or Google or the others. But today, I'm going to totally focus on technologies that run 100% on edge. Neural nets and deep learning, we've been doing neural nets for 27 years. Back then, people said, oh, no, you should use HMIs and other things, or HMMs, and we're like, no, neural nets are a great way to go. And today, it's been nice to see the whole market come back around to neural nets and deep nets, obviously. I mentioned that we're doing both voice and vision technologies. And sensory is not new at this game. Our technologies have shipped into more than 3 billion products worldwide. I put on the slide here just some of our customers. You can see that we work across a wide variety of markets and industries, from obviously lots and lots of mobile phones with companies like Samsung and Motorola and Huawei and others, to appliances, to cameras with companies like GoPro and Snap, obviously, and automotive with companies like Honda and Garmin's on here for their automotive stuff as well. To wearables galore, and PCs with companies like NEC, and then even finance using our computer vision with companies like banks, large banks like Mizuho in Japan and Banorte in Mexico and Fujitsu in Japan as well. So, and then into enterprise with companies like Zoom, who are using our technologies in their Zoom room. So a lot of different markets that we play in, and the point of this, and what I think what you'll learn in this workshop is that the sensory technologies go across a lot of different markets and platforms. And today, obviously, I'm focused on ARM as the core of all of those things. And so, from really small M0s to the A series processors. So voice control today. I mentioned, as 15, 17 years ago, I was talking to appliance companies and others, and they're like, well, I don't know, talking to an appliance or talking to my car or talking to these devices might be strange. And today it's very, very common. It's almost required. It's funny to me to see people and kids when they walk up to a display and they kind of do this with their finger to try and make things bigger or move around. And if the display doesn't do that, they're like, wait, I should be able to interact with the display that way. And voice, I think, has very much become that way. And so there's a lot of different voice controlled products that are out there, from appliances to automotive to cameras to conference room to elevators, enterprise, lighting, medical, mobile applications, mobile phones, smart home, smart speakers, thermostats, wearables, et cetera, et cetera. And I put just a few pictures up here, and these are all products that are based on sensory, from the Farberware microwave oven, where you literally buy the microwave, you put it on your counter, you plug it in, you start talking to it. So there's no, well, I first got to, get on my Wi-Fi, and then I got to name it, and then I got to sync with the skill, or none of those things are the case. You just buy it, plug it in, and start using it. So again, just kind of a smattering of some of the cool products that our technology is used in today. But voice control is here. It is the most natural means of communication with a product. And so there's going to be a lot that we're already doing, and there's a lot more that's coming. And there's kind of been this discussion about should it run on device or should it run in the cloud? Well, the cloud is great because we do all these things, but on device is extremely important for situations where I don't have connectivity to the cloud, or there is expense in using the cloud. Every time you go there, there's expense in doing that. To privacy concerns, where I wouldn't want a camera always on and watching the whole thing and sending everything to the cloud. And I don't want that with a microphone either. And so again, the focus here is, there's a lot we can do on device. Let's talk through what that is and how those things might work. So what runs where? So I've got I look at it as kind of the inner edge, the outer edge, and the cloud. And so today I'm going to focus on the inner edge and the outer edge. So on the inner edge, it's DSPs and MCUs with RTOS, without any RTOS or simple RTOS. And so in the ARM family, it's the Cortex-M series. And so it's the M0, the 33, the 55, the 4, and the 7. We run on all these today. And so technologies that we run there are primarily our truly hands-free technology. And so this provides wake words. And there are 3 types of actually there's 4 types of wake words that we support today. The first and most common is a fixed wake word. It works right out of the box. You don't have to train it. You just have to know what to say, and you say that. The second is a user-defined wake word, where I want to define my own wake word. I don't want to say Alexa to something. I want to say Jeff Smart Speaker as an example, or whatever I want. User-defined wake words are nice because they are user-defined. They're language independent. I mean, if I want to, be geeky and speak Klingon to the thing, I'm going to speak Klingon to the thing. I can do that. The drawback of a user-defined wake word is that they're user-defined. So if somebody defines a phonetically really poor wake word, then it's not going to work as well. Now, In our enrollment tech, we have a lot of checks and balances. Is it too short? Is the background too noisy? Is it too repetitive? Is it too long? Whatever. And so we can really help with those things. And then there's an enrolled fixed wake word. So I have a wake word. I have to say that wake word, but I enroll saying that wake word. And then what that provides for the product is not only do I know that the wake word was said, but I know who said the wake word. And it can adapt to my voice, my accent, whatever. The fourth one is a brand new one that we're running now, which is continuous adaptation. So this is really interesting. It starts as a fixed wake word. There's no enrollment. I just start talking to this thing. I say the wake word and it responds to it. But as it's running along, it starts keeping track, and it can track right now up to 5 different users. So it's ideal for things that are shared around the home, whether it's TVs or smart speakers or thermostats or smart home kind of lighting control. And the point is that without going to the cloud, the technology can continuously adapt and improve, not only improve for the accent, but also then start identifying who's saying what. And so there's some interesting things you can do product-wise with that. And then Truly Hands-Free also includes small command sets. And I'm going to show you a demo that I think would be really interesting for in an appliance as an example. So I call all this inner edge. So then the outer edge are application processors. So this is the Cortex-A series. And here we can run all of our technologies. So Truly Hands-Free, the wake words, the speaker verification, the small commands, as well as our Truly Natural, which is a large vocabulary natural language speech engine with NLU, and also our Truly Secure, which is today includes both face and voice biometrics. So on the outer edge and on the Cortex-A, all of these run. And so mixing these together within a single product can be very interesting. I can run very low power wake words, for example, and then I can run the Truly Natural language grammars or computer vision or other things on the Cortex-A series. And then today, obviously, we're going to talk about and demonstrate our Truly Natural actually moving from from down here only to up here to the inner edge, running on the M7. So our technology suite, again, Truly Hands-Free. This is the wake word. This is phrase spotted commands, and it can run across the ARM platform. Truly Natural runs primarily, it used to run just on the A series, but now also on the M7. And I've got an actual live demo running on an ST board that's based on an M7 that I'll show you here in a little bit. And then we've created this new tool called VoiceHub. VoiceHub really brings Truly Hands-Free and Truly Natural into products very quickly. In the past, it used to be that customers would come to us and say, okay, we want this wake word, or we want this natural language grammar, or we want this command set. We'd say, okay, let's go through it. Let's make sure everything's set, because we can't make a change. I mean, making a change we can, but it's going to take time and money. Then it's going to take time and money to actually collect the data that we need and then do this development. And then we deliver it. And then if the customer said, oh, you know what, instead of this word, I want that one, it'd be like, okay, we got to go out, more data, more development. VoiceHub simplifies that whole process. And if you haven't seen VoiceHub already, it's going to blow you away. I have seen some early registrations for VoiceHub, so we can kind of work through this together. But it's a fantastic tool. We have more than 700 companies and developers that have access to VoiceHub now, that are using not only for proof of concept and demos, but also for production. We've got several customers that are releasing product today based on VoiceHub. And again, ARM's a big part of that, because we can run across those different platforms. So a lot of flexibility for development and products. And then we've got our Truly Secure line. This runs on the A series. So this is authentication. This is speaker verification. We've actually had customers use this to unlock phones. It's secure enough that I can say my voice password and say, okay, yeah, that was actually Jeff saying the password. Our sound ID, Truly Secure Sound ID, this is where we've defined 16 sounds like glass break and doorbell and dog bark and baby cry and coughs and sneezes and a variety of water running and a variety of different sounds. This today can run both on the M7 as well as the A series. And then our Truly Secure verification. I'm sorry, I got these backwards. The authentication is the Face ID, and the verification is the voice print. So this is the entire technology suite. And again, all of this runs on device, and all of this runs based on ARM platforms. So then I mentioned our VoiceHub. So again, this is a total game changer. So at this point, what I want to do is I want to jump out of the PowerPoint here and go to our VoiceHub. So what I'm sharing here is our VoiceHub. And I can start, I can say, okay, I want to do a new project. And so here I can decide, okay, do I want to create a wake word or multiple wake words? Do I want to create a simple command set? This is phrase spotted command. So this can be 1 to up to 40 commands that I can create. Or do I want to do a large vocabulary natural language grammar using our Truly Natural? And so these are the 3 options. So for example, I can just pick the wake word one, which is here. And so actually, let me select that one there. Okay, so here I first, I name it whatever I want. So, this one as an example will be the ARM wake word. And you can see that I've already created that one. So I name the project that I want. Then I come over here and I select the language. And so here there's a drop down, and all these languages are already supported within VoiceHub today. So you can see there's a couple different English ones. There's UK English, there's US English, there's US Kids English. And by the end of this month, we will add Indian English as another English accent. So there's a lot of different languages that are already part of VoiceHub. And in total, we support more than 24 languages today. And so we're adding those languages to VoiceHub. And so you can see that I can select that I want the one I want. And you'll notice also that there's like 3 different Mandarins here. So mainland China and Taiwanese and kind of a universal. Same with Portuguese, is it's Brazilian Portuguese or EU Portuguese, and same with Spanish as well. If I'm using the Asian languages, I will actually enter in the characters in those languages and build them out. So we're not asking people to try and Romanize those languages. No, you'll actually use the characters from those languages. And so having all this flexibility in language supports is really amazing. It makes it very easy. So for me, I'll stick with US English because that's my accent. Then we start with we pick the initial size. So this really depends on the platform you're running on. If you're running on an M4 that's limited in memory, well, maybe you need an 80 KB model, as opposed to if I'm running on an A series, well, then I'm going to use a 946 KB model. The larger the model that you pick, the better the general performance will be, because there's more granularity or information that the technology has to work with. But there's a couple different things you have to consider. One is what is the product? If it's if it's a wearable, then I've got a really close talking, I've got great signal to noise ratio, and I can run a much smaller model. But if it's an IoT product where I have to use it across the room and it's noisy environment, then running a larger model is going to be better. So there's a few things that you have to kind of think through, and that's what's the type of product, how much memory do I have? I mean, if I'm running on an M4 and I have limited memory, then it is what it is. I can't change that. And so those are kind of some of the thoughts that you have to decide on. And you'll notice that it says initial size. So in VoiceHub, you can pick a size, and then it will start at that size. And then depending on what you're entering and how many wake words, if I'm entering 10 wake words, then it's going to start at that 946 KB, and it's going to grow from there. It doesn't grow linearly, but it does grow as I add more phonetics to that. So this is kind of the initial size. And then you can pick the output format that you want. And so here, the default is just our SDK that would be ideal, obviously, for the A series. We've got SDKs that run with ARM as the base, and then with Linux, Android, iOS, Windows PC, whatever. But also you can go in here and you can see all of our different chip partners, and many of these are ARM based as well. So whether it's the Ambic, which is running on an M4 as an example, or you basically just have your straight ARM Cortex-M4 here as well. So if I'm running on a chip partner that's using an M4, you can use this one, and typically it's just going to run straight away. And we do have some specific ones with some of our chip partners, but you can see there's a lot of different options in here. And again, many of these are based on ARMs. And so the demo that I'm going to show you in a bit here is the H7, where we've compressed it down so I can take a large vocabulary and run it on that M7. So then I just type in the wake word that I want. So hey, Cortex, as an example, and I hit enter. And so that now is all set up to build that. And you notice that this little speaker icon is over here. So I can press this, And what you'll hear is a TTS engine that basically plays back what the recognizer is expecting. So if I hit this now, it's supposed to play something here. Oh, and it might not work.
Hey, Cortex.
There it goes. So yep, that sounds right. Now if I did something like HBO as an example, and I wanted to recognize that as a wake word, and I just type it like that and hit the speaker icon. It thinks I'm just saying "hubbo" because it's trying to pronounce that. And so having that built into the tool is really, really nice, because I can say, oh, that's definitely not what I want. So if I put spaces between it and then do it.
HBO.
Oh, yeah, that's the one I want. So having kind of that intelligence built in is super nice. And so you're basically hearing what the recognizer is expecting. So if there's some word that you type in, like Renaissance chips, as an example, also based on an ARM core. Is it Renaissance? Is it Renaissance? And so by typing that into VoiceHub and then playing that speaker icon, you can kind of hear the pronunciation that the recognizer is expecting. So if you need to, you can phonetically spell a word such that it works really well as well. So once I'm done typing in the wake word or wake words that I want, and again, VoiceHub supports up to 10 wake words running at the same time. Then I hit the build button. It usually takes about an hour to build a wake word. And the reason for that is a wake word is all about a nice balance between false accept and false reject. You want to make sure that when you say the wake word, it responds, and just with me talking constantly, it doesn't respond until it hears that wake word. And so having that balance is really important. And so what we've done is we've created a proprietary approach to data, or synthetic data, where I'm not recording anyone saying that wake word, yet I can, when the tool is done with that, it's going to produce a binary, a file, a model that's going to work very well and have a nice balance between false accepts and false rejects. So instead of waiting the hour for that to build, here it is, and it's already built. So then you can test directly on the PC, and just press and connect to, you'll just press this button and you can test on the PC. Or as I like to do, I like to test it on my mobile device, just so I have something that's outside the PC, just as another thing to test on. So I would select, and if I don't already have the application, you can download the application, this little APK that we've created. So over here, this is my mobile phone. So here you can see VoiceHub, and it's the latest version of VoiceHub running. And I've already got a wake word in there, our standard wake word. So when I say Voice Genie, it's going to say, oh yeah, I heard that. And so again, I'm just screen sharing my phone here. So I can download this application, which is here. Or if I already have the app, then just hit download model. I say I accept the terms here. And now I've got this QR code that I can scan. So two options. One is I can scan the QR code, or two, I can actually download the physical model, the binary, and then using our SDK or using one of the partner chips, you can grab that and you can load that directly in and run it. So you'll remember that I selected 946 kbyte for the initial size. Well, for this wake word, it came out to be 933. So it's a little under that. We can also hand tune models. So VoiceHub's all about, it's fast, it's free, there's very little development time. But we can also hand tune models where we actually go out and record actual people saying the wake word. Our linguist group then goes through and does all the development, tuning, and tweaking that's necessary. And there's time and cost associated with that. It typically takes about 2.5 to 3 weeks to create a custom wake word. And if it's in other languages, then there's data costs involved, because we have to go out and gather those people saying it. So again, VoiceHub's really nice because it sets all that aside for now and lets quick development. So anyway, so I can download the model, or using my phone here, I can select scan QR code, and then I just scan that QR code, and you'll see that it loaded the wake word over in here. So now I can just say, hey, Cortex, and yep, it got it, no problem. And I can say, hey, Cortex, in the middle of a sentence, because it's a always on listening wake word. And if I'm just normally talking, I don't want it to go off, but every time I say, hey, Cortex, then I want that to be recognized. And so you can see how fast the responsiveness is. And again, this is all on device. There's no traveling anywhere, obviously, and confirming or going to a cloud. So very simple to make a wake word. Type it in, build, in about an hour, you've got it, and then you can run the wake word on a mobile device, iOS or Android, doesn't matter, or directly in your product. So whether it's running on a module or on one of our chip partners, on the ST board, I'm going to show you here in a second. It's very easy to do all that process and get everything put together and running. All right, so let me bounce back to my presentation here for just a second. Okay. So voice control everywhere. So appliances and more on an M4. I like the way that sounded. So appliances and more on an M4. So what can we do on an M4? It's a smaller platform. It's typically lower MIPS, lower memory. So what can we do? And so a couple ideas here is one is no connection, no problem. This doesn't require any internet connection. I don't have to have Wi-Fi built into it, obviously. There's no need to connect to my home Wi-Fi, which is a hassle. I've got these smart plugs all over my house, and when Amazon built out their ecosystem, I'm like, this is fantastic, and it is. I can control lights from in different rooms and do all sorts of stuff. But those little smart plugs are a pain in the butt. So you have to buy them. Number one, you have to have an Amazon or a Google device to actually control it. So you have to get that as well. Then you buy this thing and you plug it in, and there's this user manual thing. And it's really complicated. Everyone is different. You press and hold this button until the light flashes quickly, flashes slowly. Does it flash green? Does it flash orange? What does red flashing mean? Blah, blah, blah. So then you get that. You have to have your phone there. You have to download their app. And so sometimes there's a QR code, so you can do that. So you scan that, and then you download their app, you install their app. Then you have to follow that. Then you have to get that smart plug onto your Wi-Fi. And so it's a little complicated. As you don't know how to do that, then it's really complicated, obviously. Then you do that, and then you have to go in, and you have to find the skill, and then you have to enable the skill. I mean, there's like 10 steps. And a geeky person like myself, I'm going to do it, and I'm going to go through it. But my wife should never touch it. She'd just be like, no, I'll just go flip the switch. I don't know how to do that. I don't want to do that. And so there's a huge percentage of the population that is not going to go through that hassle of connecting to their Wi-Fi. I mean, it's just how it is. And it's amazing to me how often these smart plugs stop working and they have to be reset, or what happens if the power goes out. They don't automatically reconnect, and sometimes you have to go through this whole process again. And so again, voice control everywhere. On the M4, I don't have to deal with any of that. So a wake word and a phrase spotted command set. So I'm using a dishwasher example here because this is one of my issues. As I've gotten older, I have to wear my reading glasses, and I only wear them when I'm reading. So a lot of times they're not on. And so if I am starting the dishwasher, and ours looks similar to this one in the picture, there's little tiny text, and there's a little button underneath it. And so I'm always doing this kind of thing where I'm reaching out and kind of going that to make sure that I can see the stupid, small text. And so again, can't see the small text, no problem. Just say what you want. So again, the concept is let's bring intelligence everywhere. All right. So jumping out of this and back to my my VoiceHub here. So I want to start a new project, and I want to do simple commands. And so here I'm just going to call this commands, whatever. I'll keep US English. The wake word I'll pull actually in the Cortex wake word that I have already developed. The size I want, again, depends on what platform I'm running on. Do I want to start at 80 kbytes, or do I want to go all the way up to 8 megabytes, or 2 megabytes, or 1 megabyte, whatever. So I'll just keep it at the standard at 1 megabyte. And then again, the output format, is it a sensory SDK and running on ARM with a Linux or iOS or Android, or is it one of our chip partners that are ARM based as well? So then I just type in the commands that I want. So I want pro wash as an example, and maybe tough, normal, light, express wash, whatever. I just type all these in. And again, I've got the option over here to press the speaker icon so I can hear what it sounds like, what the recognizer is expecting. And so then I can type in all the commands that I want. And then the same thing, go down here and push build. With a command set, it takes a little bit longer because there's a number of commands. So a command set could take a couple hours to build. So the beauty of VoiceHub is that once you're signed in and logged into it, and you create a project and build it, when the project is done building, you'll actually get an email from VoiceHub saying, hey, your project's ready. You click on the link and it immediately opens up the project. The other thing that's really cool about this tool is the share button here. So if Joe and I are working on a project together, I can hit the share button and I can share this project with Joe, and he'll get the whole project, and then he can modify it, or he can work with it, and he can share it back with me. And so as far as kind of working together as a group, even though we're independently or we're located in different areas, or we're all working from home right now anyway, moving things around is very easy. And I do this all the time with customers. I'll create a demo just because it's easy for me now. And then I just share it with them and say, hey, here it is. And then they can start and kind of build on from there. So now let's say I went ahead and entered the rest of these. And so to shortcut it, so here's my dishwasher commands. You can see here, actually, I'm using a very small size, a 147 kbyte initial size, because I do want to run on a smaller platform. And I've got the same as the output here. And you can see that I've got my commands in here. So it's pro wash all the way to start and cancel. So just basically those buttons that I would have. So then I build this, and it's going to pop up this thing saying, it's here's VoiceHub. This is the SDK version. This is the name, the language, the size, whatever. And then hit continue. Now this should build very quickly because I've already built the set one. So it's basically just rechecking that it's got the latest technology code and whatnot. So now when I'm ready to do some testing, again, I can pop up my phone there and I can download this model. And so I'll just take my phone here and I'll scan this QR code. This is so cool. It's so easy to use. I'm not a speech technologist. I'm not an engineer. I'm not a linguist. I'm a sales guy, and I'm doing all this myself. And so if I can do it, you can do it. I'm sure about that. So now you can see that it's loaded the wake word over here. So this is a custom wake word, and then the command set. So I can say things like, hey, dishwasher, pro wash. So no problem. It recognizes the wake word, it recognizes the other thing. But a lot of times people say things like, hey, dishwasher, I want pro wash right now. So even though I said I want before the pro wash, and then I said right now afterwards, the beauty of truly hands-free phrase spotting is that it can spot that phrase that I'm listening for. So when I'm ready to start the, when I'm ready to start the process, I just say, hey, dishwasher, start. And it's going to say, okay, good, the dishwasher is going. Hey, dishwasher, express wash. And it's going to say, okay, I'm going to run that one. It's so much easier than walking over and looking at those little buttons. And again, because we can run this on so many different platforms from, we probably couldn't run this demo on an M0, but for sure M4 and the others, the M55s and the 33s, we can run it on all of those for sure. It means that I can add this intelligence everywhere. So whether it's it's a dishwasher, it's a coffee maker, a stove, or whatnot. This is very simple. A lot of people will see this and they'll say, "Oh, is this a natural language?" And I'll say, "It actually isn't. There is no NLU, but that phrase spotting kind of gives it that appearance." And the beauty of this is that because it's so good at spotting that, it's also really good at in inherently spotting it in high noise environments. So, using this, I shot a little demo of our truly hands-free running in a smartwatch, and I was in a very noisy restaurant, and people are talking and dishes are banging, and I'm just sitting there saying, yeah, what's my step count? How about my heart rate? And it works very well. So this is all part of truly hands-free. So again, going back to the PowerPoint, this is all on the inner edge. So this is the smaller platforms from M0 all the way up to the M7. Okay, so let me jump back to my presentation here. And from here, so that was my dishwasher example. So here's another example. So, natural language anywhere. So for example, a bus or a train terminal. So there's no connection, no problem. So that some of these things are connected, some aren't, whatever, it doesn't matter. There's no need for data costs and going to the cloud. And so again, using machine learning on an embedded device saves all those issues. And again, the concept is intelligence everywhere. So if I bounce out of here and go back to here. So what I did here, so this is our truly natural. So I started a new project, and this is a large project. And so I just named it as my bus train stop. Again, select the language that I want. It's all the same languages that are part of truly hands-free. And then select the size. So in this case, and just so you can see that, that's 7.3 megabytes. It's not 73 megabytes, but I can go much smaller. I can say, you know what, I want to run this as a really small 147 kbyte acoustic model. I mean, that would be really small. So again, it really depends on the platform that you're running on. Choose the output format that you want. Here again, I'm going to use the same wake word that I already created back, a couple slides ago. And then with Truly Natural, we also have an out of vocabulary rejection slider. So, I've got it set at 15. I could make it more rejecting or less rejecting. And this, even though this is on a line, it's really not linear. So going from 15 to 27 is a pretty big jump. I usually find that somewhere in this area, for me, not 15, 20 feels pretty good. But this is something that you as the developer or the company gets access to and can control. So then we go down here, and this looks very different, obviously, because now we're talking about natural language. There's a lot more variability. There's a lot more that I can say to this. So you can see that there's a vocabulary tab, there's a slots tab, and then there's the grammar tab. So typically, I think of this from a top-down perspective. So I start with the intent. And so you can just hit the plus thing here, and you can add it. You can add as many intents as you want. For me, for my bus train terminal, it's all about questions. People are going to ask questions about things. So I just have one intent. It's question. So then I kind of skip the slot and I jump right down to the phrases, and I kind of think through, well, what are the questions? And so the first thing is, well, somebody might say something before the question. So I create a slot for intro, and I can open up that slot right here. And here it is. When is, what time, how much does it cost, what's the cost to, which, what time is the, when, whatever. And so I can just type in the phrases that I think people would say. And you'll notice sometimes that there's a question mark. What that means is that the word preceding is optional. So somebody could just say when is, or somebody could just say when. And actually I've got that kind of here twice. So I really don't need this one down here. And you also know that this is page 1 of 1. You can have hundreds, you can have thousands of pages, you have tens of thousands of pages. So a truly natural project can be very simple, or it can be very complex, a lot going on. It really depends on what you're trying to accomplish. Okay, so back to my, and you'll also notice that there's some predefined slots grammars that we've already created. So if we wanted to do temperature as an example, I could just grab oven temperature, Celsius or Fahrenheit or thermostat, and I can just grab these and I can just drag these down into my phrases as I want to. So that having the predefined slots is really handy. Okay, so back to my vocabulary tab here. So the first one is intro, and then I've got bus or train, just as and the intro is always optional, you can see here. Then I got bus or train. So what's under bus or train? So I just said, when's the next bus, the next train, what time will the next train arrive? And again, next is optional. And so I just kind of think through the different things I might say. And as I was creating this, I thought, well, people want to know times between cities or how much it costs to go to a city. And so I created a city tab, a city slot. And so you can see I've drugged those in down here. And so cities, I just use cities that are around me: Portland, Seattle, Medford, Eugene, and then San Jose, Tigard, Westland, whatever. So I just type these in, and as I enter them, they're automatically built into the vocabulary. Okay, so this is kind of a simple one, and then I have another one which is conjunctions. So conjunctions are go to, for, get to. How long does it take to get from here to here, as an example? And so built that out. And so I've got those, and you can see I've worded it in 2 different ways. You might say conjunction first, and then you might say I want to take this train to this bus or train, here to here. And then I added cost, and so under cost slot, basically it's just what's the cost to, or cost. How much does it cost to go somewhere? And so this whole vocabulary, it took me probably 30 minutes to kind of think through this. And the beauty of VoiceHub is then as you start using it, you can test it. And if something's not being recognized, you can say, oh, well, it's because I didn't build that in the grammar. And so it's very easy to go in and then update and modify. So once I've got what I want, I can build it, obviously. Now, building a truly natural is going to go very quickly. I've already got the wake word built, so I don't have to worry about that balancing between false accept and false reject. So this is a custom build. It takes a couple seconds. Then I can check the coverage tab. And here it auto-generates a grammar or optional things from all that stuff that's above. And so you can see there's literally thousands of different things that I could say. how much does the train cost to Clackamas? Blah, blah, blah. So those are all automatically generated. Then again, I can test on the PC, or I can, as I like to do, I can download and test on my mobile device. So I'm going to do that. So I'm going to take my phone here. I'm going to scan the QR code, same thing. And then that loads that all in there. And so on the phone, you can see it gives me a lot of different examples of things I can say. But I can say things like, hey, Cortex, how much does it cost for the bus to San Jose? You can see it recognized the wake word and what was the cost to San Jose. And it also pulls out the NLU, which is really nice. Okay, so it was a question, obviously. That's my only intent that I have. What does it cost? And then I use the conjunction one, bus or San Jose. And then I use the cities, San Jose. And so this is the recognition result. This is the NLU that pulls out. Hey, Cortex, which train goes to Beaverton? And there it is. Hey, Cortex, when does the bus arrive from Clackamas? Hey, Cortex, how long does it take to get from Medford to San Jose? So this is all just being pulled out of that grammar that I created. And literally, again, it took about 30 minutes to create all this. And if I decide I want to add cities, I just type them in and add them and then rebuild it, and they're automatically populated into this. So it's again, really fast. Okay, I want to keep going because I want to get to my actual demo running on the M7 here. So let me jump back to here. One more demo that I was going to show you. This is from one of our customers, MWS Fabrication. They use our VoiceHub and they created an elevator application, which is fantastic. It works extremely well. In today's world, nobody wants to touch anything. And so again, this is all running in this panel and very, very quick. So I'll just play just a couple seconds of this so we can keep moving here.
All right, guys, a little before and after. This is the old Otis button. This is the new MWS button. Elevator going up. Picture. The old Otis COP, the new custom COP. Elevator, second floor. Go. So our twist on the.
So you can see how quick it is. Use VoiceHub just to create all the different things, first floor, second floor, 1, 2, whatever. And so again, you can build that out very quickly. In my time remaining, I wanted to talk about Truly Natural actually running on the M7. So this is new, it's very exciting. So what does this mean and why does it matter? Well, it's number one, it's natural language on a smaller, lower power processor. It's natural language, includes the NLU or the natural language understanding. I can bring cloud-like voice control to on-device. Up to 20,000 unique phrases that are running between 1.6 and say 3 megabytes. So that's not 16, that's 1.6. So the demo I'm going to show you in a minute is like, I think it's about 1.6 or 1.7 megabytes for everything, the technology code, the acoustic model. And obviously this opens up a whole new category of products and ideas for more cost-sensitive products. And so I'm using our chip partner ST and their board for this. And the demo basically, you'll see speed, you'll see accuracy, natural language, NLU, of course. In this demo, there's more than 10,500 unique phrases that can be recognized. This whole thing's running in, I think it's about 1.6 megabytes and built and ready in just minutes. So let me jump to the VoiceHub project that I created this with. So here it is. So it's my coffee machine. Using English, and I'm using a very small acoustic model because I want this to run very small on that chip. So 147K bytes. I'm using my wake word that I already created, and then basically I've created one intent, which is just a drink order, and this is obviously for a coffee machine. And then I jump down here to, okay, what are people going to say? Well, there's going to be an intro, like I want or give me or whatever. And again, I just define those out here, just typed them in whatever I want. And that's optional. And then there's a size. And so the sizes are things like large, small, tall, venti, medium, whatever. And I can add whatever sizes I want. And that's also optional. Drinks are required because obviously I'm going to order a drink. And so the drinks basically have all the different drinks I can have. So it's apple juice, cafe, cappuccino, double espresso, green tea, hot chocolate. Those are the drinks I have in here right now. And for the most part, if I open up these, it's just hot chocolate. So hot chocolate, there's really only one thing you'd say with that, and it's hot chocolate. But some of them, like the cafe, it could be iced, it could be latte, it could be Americano, and those are optional. So a couple of ways you could build that out. And then I added modifiers and with a question mark. And modifiers are just defined as, with sugar, sugar-free, with cream and sugar, whatever. And so I built all that out, and then I can build this. And then I can go to my phone here. And I can scan a QR code. So download, model. Scan that, and that loads that whole grammar in there. So now I can say, hey, Cortex, give me an espresso. So I love the gimme because, I mean, it's not proper, but that's what people say. Hey, Cortex, I'd like a tall cafe latte Americano without cream. So there's a whole bunch of information. There was a lot of different modifiers and variables that all went into that. Hey, Cortex, I want a tall hot chocolate. Try that again. Hey, Cortex, I want a tall hot chocolate. So recognize everything that I said there. Hey, Cortex, I'll take a large green tea, sugar-free. So super fast, very accurate, no problem. Now, if I want to add things like, let's add a different size. So let's have the cool size, whatever. And let's say I want to add another drink too. So I'm going to add, I'll add a drink here called pumpkin spice latte. Add that one in there, hit OK. Okay, now I've added that. So then I go into my drinks and I want to add the pumpkin spice latte. So I just drag this down into there. Okay, so now that's in there. And I can then go back here and build this. Oh, there's nothing in pumpkin spice latte. Beauty of pumpkin spice latte. So the beauty of the tool is I forgot to add that in there, and it says, hey, you're missing something there. So that's now added in there. So now let me try and build that again. No problem. It's great to have that error correction for people that make mistakes like myself here. And now I've added those two options here, so I can download and test that new option. And so I just scan this QR code again. So now I can say things like, hey, Cortex, cool size double espresso with cream. So you can see that I just added that new sizing, and it's already part of the app. And so as you're developing, or as a company's developing products or the voice interaction, and through use or through testing or beta site, you can go in and you can say, hey, this would be nice to add this. I want to include this in the product. Or you notice how people are using it. It's very easy to change those things. And I can say things like, because I added the pumpkin spice, I can say, hey, Cortex, I want a small pumpkin spice latte. So because that's in there now, it's I've added it, and now that's part of the grammar. So very easy to use. So now what I want to do is I want to take this whole project, and so I would download the model. So again, if we look at the model size here, so the whole thing is actually it's way smaller than I said. This is 1.2 megabytes, and that includes the wake word and the natural language grammar that I did. So again, because I use very small, I use a small wake word, and I use a 147 kbyte acoustic model. So instead of scanning this, I would download this model, and then using the ST tools in this case, I would load this into my ST board. So if I change my screen here, let me go to a different camera, and okay. So you should now see my the ST demo board, which is right here. I'm just going to hit restart there, and then so then I'll just kind of zoom in my camera here. So hopefully you can see this pretty well. So you can see that it's got the wake word on there right now, and it's running, and it's listening for me to say things like, "Hey Cortex, double espresso with cream." And so you can see that it recognized what I said. It also shows the NLU. So all of that's being pulled from VoiceHub into actually running on this demo board. And because I added things like, the pumpkin spice, I can say, "Hey Cortex, a tall pumpkin spice latte with cream." So got the size, got the drink I wanted, and it got the modifier as well. And so again, being able to go from the VoiceHub tool, very fast, very easy, to actually running on a real piece of hardware. That's amazing. It's a total game changer for a lot of companies and development projects. So this has all been sensory. Big focus on our VoiceHub tool because it really changes the way that companies can think about how to add voice to everywhere. How do this concept of intelligence everywhere, being able to do that and do it across a variety of ARM platforms from very small to the A series, where we can basically run all these different technologies. It's a total game changer, and we've already seen it change the kind of the mentality and the thought process towards what is my voice strategy. Now today we didn't spend any time talking about biometrics, but again we can do computer vision, we can do voice verification, and all those run on the A series today. We didn't really talk about or do demos of Sound ID, but the Sound ID can run both on this same M7 as well as on the A series. So there's a lot of different technologies, and you can mix and match those technologies. So we have a lot of customers that will use a truly hands-free wake word and then a truly natural grammar, like the Farberware microwave that's in the market right now. That's that concept of buy the microwave, plug it in, start using it. So I can just say the wake word, and then I can say, cook for 30 seconds, or set timer for 10 minutes, or set the time for 11:26 a.m., or cook my defrost a 2-pound chicken, whatever. That natural language is in there. And so building that all into something that runs on device is magical. So that I think that is all of my slides and presentation. So appreciate the time, and let me know if there's questions. Happy to answer those now.
If any of the interactive participants want to ask a question to Jeff live as well, if you just raise your hand and then we can invite you up. Yeah, it looks like we've got Eleftherios. If you want to come off mute.
Yes, thank you. Really impressive. The question I have is, do we have some kind of metrics of how well each model will perform based on its size?
It's a really good question. It's hard to do a matrix because there's a lot of different variables that are involved. So some of it is what is the wake word of the command set. I mean, if they're phonetically weak, then that won't perform as well as obviously one that's much stronger. But generally speaking, the larger in size I go, the better the performance is going to be. But it's really not linear. I've seen some comparisons between a 128K byte wake word and a 500K byte wake word. And because they were both in a close talking application, in a wearable as an example, not a big difference. Where you're going to see the biggest difference is where you're going to far field, where it's 5 meters and it's in a noisy environment. Running a small wake word there is going to have a much greater problem with FAs, in particular FRs, faults rejects, than you would with a small, than you would running a larger model.
So I guess it's better to do some tests, some basic tests, or based on your vocabulary, your application. Okay.
Yeah, it really is, and the beauty of VoiceHub is it makes it very easy to do that, obviously. So it's easy to put those tests together. And we've got one customer right now that's trying to decide between 2 wake words, and they're very similar. The difference is one starts with hey and the other one starts with okay. They want hey because it's more natural, but okay, that K sound is phonetically better. And so they actually did a test using VoiceHub where they built out the models for both of them and then ran it through our simulation tools that we provide as part of our SDK. And turns out that, yeah, okay is phonetically better, but it was within 1 or 2 percentage points. So they're going to go with the one that they want, they prefer. And so just doing those little tests. And as I mentioned, in our SDK, we include a tool that allows you to take a bunch of recordings and run it through. So it's not like, hey, let me get 500 people in here to do a quick test. You can, as long as you have that data, you can run it through quickly. That brings up another comment. I appreciate your question because people ask me all the time, or they tell me, "Oh, Jeff, we did this development and we're testing, and the recognition's horrible." And I'm like, okay, what are you doing? Well, we have 4 people and we tested all 4. And I'm like, well, okay, so 1 person had a problem, the 3 didn't. So you're saying it's a 75% accuracy. You know, if you did that same test with 100 people and 1 person had a problem, you'd be delighted and tell me it's a 99% accuracy. So, you know, with speech recognition, there is value, I think, in doing a little anecdotal testing. Just how well does it work? Is it working with my voice? Is it, you know, am I getting the right things? But you really do need a statistically significant sample to say, hey, is this really working? Because again, with 4 people, you might just have 1 person that had one thing that just didn't quite line up. And with, you know, if you test with 100 and you still had that 1 person, well, you'd have 99% accuracy. Fantastic.
Great, thank you.
Yeah, thank you.
We do have a question just coming on the Q&A. I know Joe's writing an answer, but we can ask the question live. Do you have a list of supported SoC development boards?
Yeah, it's a good question. So every chip partner that's listed in the VoiceHub tool means that we've ported to their platform, and I believe for the most part that what that means is you'll be able to create something in VoiceHub, and then they'll have tools in which you can integrate it in. So as an example, you know, for sure that's the case with ST, because I showed you this demo here just a minute ago. And most of our chip partners, that's the same case. I don't know that we actually have a direct correlation, but I believe that if it's in VoiceHub, not only is it formatted and works with that partnership, but it also means that you should be able to use their tools to run the demo on. But it's a good question. I'd have to double check that is the case across the board. Generally speaking, it should be.
Great, thanks.
Any other questions?
Yeah, we just got another one come through from William. Has anyone attempted to use this in a safety critical environment? The consequences of getting a command wrong in 1 million attempts could be very high.
Yeah, that's a really interesting question. So we do have a couple of customers that are using for medical devices. One is a company that's created a product that's used for eye surgeons. And so when they first came to me, I was like, oh, I don't want to touch this with a 10-foot pole. And they said, no. What we're doing is we're replacing the need for the eye surgeon to put down tools and reach over to a screen and touch a screen to change to get certain information or to change settings. It had nothing to do with I'm going to fire up the laser and shoot this laser across the room kind of thing. And so from that perspective, it's used as a means of making it a lot easier for the doctor to make changes to things. I've got both hands on the tools. I'm doing something, and I can just talk to this tab. It looks like a tablet kind of device. I can just talk to it, and it shows me different options or different screens or whatnot. It has nothing to do with the actual, anything that would be life-threatening. So we do have some experience there. This product is approved, and it's in use today. But if I had somebody that wanted to do a product where it was life-threatening, I always joke about in car environments. We're in a lot of different car types of environments, from products like Google Waze and the Garmin products and Honda cars and others. I always joke about the fact of it'd be great to have a voice command, deploy airbag. Of course, you'd never do something like that, or apply the brakes. You wouldn't do something like that. And I think in to kind of expand that a little bit in gaming as an example. Oh, I think voice control is going to be massive in gaming. It has been a little bit now. I mean, it's starting to pick up, but the challenge is every title is unique. And how do you do that? Well, the answer is VoiceHub, clearly, because it makes it very easy to create. I created a Fortnite control set where I want to say things like, drop clip or change weapon to this, or, do this dance or whatnot. And right now, to do those things in Fortnite, it takes it takes a series of button presses and ups and downs and buttons and stuff like that. And so voice is going to be very natural for that. But I wouldn't use voice for fire, 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 fire. I can do that way faster with a button. So I don't, gaming is probably not critical, but I think it's an example of where you would your voice makes a lot of sense, and other areas where you wouldn't use it.
Fantastic. Thanks, Jeff.
Yep.
Okay, any more questions? Now's the perfect time. Okay, then. Well, I think that's about that for Q&A.
Okay, great. We were on time and a little bit ahead, so we're not backing up the next the next one.
Yeah, that's pretty good. Okay, well, if that's all there, Jeff, first of all, I think we can wrap it all up. So thank you so much, Jeff. It's been a pleasure having you present this fantastic workshop and show us all about VoiceHub. For all of our attendees, this workshop will be recorded, or has been recorded, and it will be available on demand on the Dev Summit platform within a day or two. So yeah, feel free to rewatch, catch up on this, and yeah, explore all the available content.
Absolutely. Thank you, everybody. I appreciate the interest in it, and looking forward to working with all of you. And if there's additional questions, feel free to reach out to me. Happy to continue our discussion. And thanks, Arm, for putting this workshop together. Really appreciate it. What a great platform.
Yeah, thanks, Jeff. Thank you very much.
Okay. Cheers, all.